The next question is three functions f1 of t, f2 of t, and f3 of t are given. Okay, f1 of t, f2 of t, and f3 of t are given, which are 0 outside the interval 0 to t. So from 0 to this t, the signal value exists only from 0 to t, and outside the interval it is 0. All the signals are 0. The question is, which of the following statement is correct? Option A is f1 of t and f2 of t are orthogonal. Then option B is f1 and f3 are orthogonal. Option C is f2 and f3 are orthogonal, and option D, f1 and f2 are orthogonal. So they are mutually checking whether these signals are orthogonal or not. So what is meant by orthogonal signals? Two signals, x of t and y of t, two signals x of t and y of t are said to be orthogonal if integral over minus infinity to plus infinity x of t multiplied by y of t dt will give you 0. Okay, so in other words, inside the integral you have the product of the signals, and taking the integral from minus infinity to infinity over the product of the signal means the area under the product of these two signals, or x of t and y of t, should be 0 at any time. Okay, so any time means in the whole time interval where the signals exist, or from minus infinity to infinity. So let us see, let us check option A. F1 and F2 are orthogonal. We go to check F1 and F2 as orthogonal. So in F1, in the first half cycle 0 to t by 3, in this cycle f1 of t will be having 2 as amplitude, and f2 of t will be having 1 as amplitude. So product is 2 into 1. Okay, so 2 into 1 plus, okay, in the next time interval, f1 of t is 0 into f2 of t is minus 1 whatever, so 0 into minus 1 is 0, plus in the last time interval, this interval, f1 of t is minus 2 into f2 of t is equal to 2. Okay, so this is 2 minus 4, which is not equal to 0. So we can say that f1 of t and f2 of t are not orthogonal. So we can rule out option A. Okay, and now let us check option B, which says f1 of t and f3 of t are orthogonal. So in the first time cycle, f1 of t will be having amplitude 2, and f3 of t will be having amplitude 1, 2 into 1. Okay, in the next time interval, second time interval, f1 of t will be having 0, and f3 of t whatever it is, so 0 into minus 3, so the minus 3 is 0, plus in the last time interval f1 of t will be equal to minus 2 into f3 of t will be equal to 1. Okay, so this is 2 minus 2 equal to 0 definitely. So we can be sure that f1 of t and f3 of t are orthogonal, so option B will be correct. For the sake of assurance, we can check option C and D also. So option C says f2 and f3 are orthogonal. So let's see, f2 and f3 are orthogonal. So f2 means 1 into 1, 1 plus then minus 1 into minus 3 is plus 3, plus this is positive, some positive value into positive value, this is not going to be 0. So option C is also wrong. Now last option D, f1 of t and f2 of t are orthonormal. Oh, okay, this is orthonormal, but orthonormal means it is again orthogonal with unit magnitude, that is orthonormal, right? Orthonormal signals are orthogonal signals with unit amplitude, so it should be orthogonal. So let's check f1 and f2 are orthogonal. Oh, okay, we have already checked that in option A. They are whether they are orthogonal or not, but it is not orthogonal. They are not orthogonal, so they are not orthonormal also. Only orthogonal signals should be orthonormal. Okay, so f1 and f2 of t are not orthogonal means they are not orthonormal also. So option D is also wrong. So the correct option is option B.